I'm Anil Kumar. Welcome to my series on providing solutions to previous test papers. In this video, we'll discuss complete solution of June 2018 test of International Cambridge Examination. So this is paper 9MA0, where we have questions relating to advanced mathematics, which includes functions and calculus. First, we'll just go through these questions and their solutions, and then we'll provide you with the detailed videos on these solutions. So you can actually have a look at these questions, and if interested, you can pause and look at the details of solution. Later, you can watch the video on the steps required to solve such a question. So this is based on rational functions. Then we have a question based on vectors. Question number 3 is based on absolute functions. Question number 4 is a sequence and series question, where arithmetic and geometric series have been combined. Question number 5 is Newton's-Raphson formula for approximate solution. Then we have a polynomial equation to solve, and there is a twist where the independent variable has been changed and also a trigonometric equation has been evolved to solve. Question number 7 is a trigonometric identity. Question number 8 is to model a projectile motion. Question number 9 is to find the derivative using first principle for cosine theta. Question number 10 is an application question where the a sphere of 5 millimeter reduces. We need to work on its rate of change. Question number 11 is based on partial fractions, very interesting. Question number 12 is a very good trigonometric identity to prove and related equation to solve. Question number 13, this is one of the toughest questions in this group, where we are looking at two graphs. We need to find the area of the shaded portion. The last question here is question number 14, which deals with the modeling of a population of mice in an island, and rate of change of the population is discussed. Now you can see in details the solution of these questions from 1 to 14. I also provided you with the related links which will help you to practice similar topics. Now, in case there are any doubts, you can always send an email to the address given here. Enjoy watching the videos and also look at other related solutions. All the best. This is the very first question. We are given the function g of x equals to 2x plus 5 divided by x minus 3, where the value of x is greater than or equal to 5. So as you can see here, the domain is restricted, right? So that's the important thing to notice, that we have restricted domain. So based on this, you have to answer your questions. In the example taken, we had no restriction like that. Now the question is, find g of 5, right? So function of function. So a little bit of more exercise. So when we say g of 5, that means we need to find this function g of 5 means replace x with 5, right? So we get here 2 times 5 plus 5 over 5 minus 3, correct? So that gives you g of 10 plus 5 is 15 divided by 2, right? Which is equal to g of 7.5, correct? Now we need to substitute 7.5 here and then evaluate. So what we get here is 2 times 7.5 plus 5 over 7.5 minus 3. Now calculator is allowed for this test paper, so let's use the calculator, find this answer, right? So we get 2 times 7.5 plus 5, And then we are going to divide this by 7.5 minus 3. And what we get here is 40 over 9. So you could write the value 40 over 9 as the answer, correct? So that becomes our answer for the very first question. Second one is state the range of G. Now since we have a restriction on the domain, that is x could be 5 minimum, and we know that G of 5 is, we just calculated, is equal to 7.5, correct? Earlier we had seen that when x approaches positive infinity, right, so it is greater than, means it is from 5, which is included, to infinitely large value on the right side. So when we check for x approaches infinity, we know that G of x actually approaches 2, as we saw in the first half of the video. That is the horizontal asymptote, correct? So it approaches, but it is not right there. And therefore, the range will be what? Range of this particular function will be, can be given as G of x belongs to set of real numbers where it is greater than equal to it is greater than 2, but it is, because never at 7.2, right? So G of x is greater than 2 but less than equal to 7.5, correct? 7.5 is a bigger value than 2. Therefore, the range will be from 2 to 7.5, where 2 is not included, but 7.5 is included, right? Now the question is, find G inverse of x stating its domain, right? Now, we can state the domain first. Range becomes domain, right? So that's kind of important to understand. So I'm writing in a different name. So range of G of x becomes domain of G inverse x, correct? So we know that the domain of, we can write here, domain of G inverse x is basically x belongs to real numbers where x is between 2 and 7.5. 2 is not included, but 7.5 is included, right? Now let's answer the first part, which is to find the inverse of the function G inverse x, correct? Now in this particular test paper, you are only supposed to write in the space provided, that too in the black ink. However, I'm writing these instructions just to explain you the concepts, right? So take care of that. Okay, so when we want to find the inverse, what do? We swap, right? So x and y, and then we calculate or solve for y, right? So I could write this as x is equals to 2y plus 5 over y minus 3. So we have done that swapping, right? Now we need to isolate y, so we could cross multiply. So we get x times y minus 3 is equal to 2y plus 5. Idea is to isolate y. So we get xy minus 3y equals to 2y plus 5. And now bringing the y terms together, so sorry, this is 3x, 3 times x. Okay, so y terms together, what we could do is we can bring this term here. So we get xy minus 2y equals to 3x plus 5, correct? So let me take it to the right side. I don't really want to go downwards. So here we can take y common. So we get y common, x minus 2 equals to 3x plus 5. So we get y equals to 3x plus 5 divided by x minus 2, right? So G inverse x is 3x plus 5 over x minus 2. And it's very important to write the domain, that the domain is between 2 and minus 2 and 7.5, where the value of x is greater than 2 and is less than equal to 7.5, right? So that is what the inverse is. So it's very important to mention the domain for the given inverse function in the answer also. So in this test paper, they actually help you out by stating its domain, kind of giving you a hint that that should be included in your solution, right? Now this question is based on vectors. Question number 2 is relative to a fixed origin O, the point A has position vector 2i plus 3j minus 4k, point B has position vector 4i minus 2j plus 3k, and point C has position vector ai plus 5j minus 2k, where a is a constant and a is less than 0. D is a point where AB is equal to vector BD. Part A is find the position vector of D, that is part A, and then given that the magnitude of AC is 4, find the value of A. You can always pause the video, answer the question, and then look into my suggestions. Now normally you're supposed to answer in black ink in this space provided. However, I'll give you solution, rather hint of the solution right there in the space. So we'll be having a close look at the question as we solve. So let's work with part A, where we are given that the vectors AB and BD are same, and we need to find the position vector D. So let us say that the position vector D is xi plus yj plus zk, right? Where I, j, k are unit vectors along the direction x, y, z. So when we say that AB, let me just push this. Okay, when we say that the vector AB is equal to vector BD, then AB means what? So AB is B minus A, right? So OB minus OA, right? So that is what it is. So which we could write here as 4 minus 2, right? This is B and this is A, so 4 minus 2. Minus 2 minus 3, 3 minus, that becomes plus 4, right? Equals to B to D. So X, Y, Z are D components, right? X, Y, and Z. From here, we'll take away the B components, which are 4 minus 2, 3, right? So 4 minus 2 makes this, and then 3. Clear? So that is what it means. So from here, we actually get 3 different equations. And we could actually equate each to find the value of x, y, and z. So we have x minus 4 equals to 4 minus 2 is 2. So that gives you the value of x as equal to 6, right? Now the other one is y plus 2 equals to minus 5, and that gives you the value of y as minus 5 minus 2, which is 7. And then we have z minus 3 equals to 7. So that means 7 plus 3 is 10 for z. Right? So that gives you the value of d. So vector d basically is 6i plus 7j plus 10k. Clear? So that is how we are going to find this particular solution. Now, oh, sorry, this is minus 5, this is minus 7, sorry. Minus 2 minus 3 is minus 5, and when you take away 2, it becomes minus 7, right. So that is how you get part A. Now, let's look into part B. We are given magnitude of A to C is 4. We need to find the value of A. So let's find the vector AC first. Vector AC means we have to look into these two, correct? C minus A, right? So that is, we have A minus 2, then we have 5 minus 3, and here we have minus 2 minus minus 4, right? Which is plus 4. So that becomes AC. So what is the magnitude of AC? Well, let's write the magnitude square, right? So magnitude square will be A minus 2 whole square plus 5 minus 3 whole square plus minus 2 plus 4 whole square. And this is given to us as 4. So we could write this as 4 square equals to all this, right? Which is a minus 2 whole square plus 5 minus 3 is 2. 2 square is 4. And here we have 4 minus 2 as 2. 2 square is again 4, right? So we have 16, take away 8 equals to a minus 2 whole square. 16 take away 8 is 8, right? Square root of 8, which will be plus and minus, equals to a minus 2. And that gives you the value of a as equal to 2 plus minus square root of 8, right? Now, since we know that a is less than 0, we'll take the negative value, right? So for us, a actually is equal to 2 minus square root of 8, right? So we can write the value of a as equal to square root of 8 can be written as 2 square root 2, right? So 2 minus 2 square root 2. So that becomes the exact value of a, right? So that is how you would actually answer this question. Let's look into the question 3a. If m and n are irrational numbers where m is not equal to n, then mn is also irrational. Disprove this statement by means of counter example. Right? So basically we need to provide an example which will disprove it. So we could say let m be equal to some number which could be, let's say we could take this as we know perfect square is 16, so we can take 8 and 2, right? So m is 8 square root 8 and n could be taken as square root of 2. Now when you multiply these two, in that case m times n is basically square root 8 times square root of 2, and what we get here is square root of 16, right? Square root of 16 is not irrational. We get the answer as 4, right? So that is how you could prove that this is not the case. So one example is sufficient to provide this. You could also take many other examples, but just ensure that product of m and n is a perfect square, right? So that should help. Part B is sketch the graph of y equals to absolute value of x plus 3. And second part of this is explain why absolute value of x plus 3 is greater than or equal to absolute value of x plus 3 for all real values of x. So let's sketch y equals to absolute value of x plus 3. So this function basically is absolute function translated 3 units up, right? So you could sketch it as let us say like this, right? So where this value at 0 will be 3, right? So for every increase, let's say at if I write x equals to 1, I should get here 4, correct? That's what it is. At 0 it is 3, and at minus 1 we'll get 4. So likewise we get our function absolute value of x plus 3. So we see that its range is greater than or equal to 3. Now part B is why absolute value of x plus 3, that function, is greater than or equal to absolute value of x plus 3. Now when you're looking for absolute value of x plus 3, we need to consider when is x greater than 0, when is x less than 0, right? So when you have absolute value of x, then basically it is x when x is greater than or equal to 0, but it's minus of x when x is less than 0. But when you put it like x plus 3, that negative value makes it lesser, right? So that is the whole idea. So when you are sketching, you will see that the function, when you consider x greater than or equal to 0, in that case absolute value of x plus 3 is actually equal to x plus 3. However, when you take x less than 0, in that case, absolute value of x plus 3 is greater than absolute value of x plus 3 within it, right? So this is absolute x plus 3, and that is absolute of x plus 3. Perfect, that's the difference. Well, if you sketch, then the function, this value will be 0 for x equals to minus 3, right? So you could extend like this, and this graph will be kind of like this, where at minus 3 it is going to be 0. So the one in orange is absolute value of x plus 3, and the one in the other color is absolute value of x plus 3. Okay, so that is how you could explain. Okay, so I hope that helps. Let us see how to solve this question. 4a, show that the sum r equals to 1 to 16 for 3 plus 5r plus 2 to the power of r is equal to 131798. Part B is, a sequence u1, u2, u3 is defined by un plus 1 equals to 1 over un, where u1 is 2 over 3. Find exact value of this sum of u's from r equals to 1 to 100. You can always pause the video, answer this question. Now here, you see that this sequence can be treated as a combination of arithmetic and geometric sequence, right? So we'll write this as, we're given this sequence, which is 3 plus 5r from r equals to 1 to 16, right? Plus, we'll write it as a combination of 2, right? R equals to 1 to 16 for 2 to the power of r, right? So this is your arithmetic sequence. Now the formula for, there are 16 terms here. So the formula here is that s of 16 is basically equal to, we can find first and the last value and then divide by 2. So number of terms divided by 2 times first term plus the nth term, and in this case nth term will be the 16th term, right? That is for the arithmetic sequence, right? For the geometric sequence, we have a formula which is that sum is equal to a times, you can write r to the power of n, or 1 minus r to the power of n divided by 1 minus r to the power of n, right? So that's how you can use the formulas. Now using these formulas, let's find out the sum. So, well, we need to find the first and the last terms also. So T1 is basically equal to what? So when I substitute 1 here, I get 3 plus 5 times 1, which is 8, right? And T16 is 3 plus 5 times 16, so that is 83, right? So we get 83 as our nth term, the 16th term, right? So we can write sums of this as equal to, so this implies this sum is what? So the first part, we could write this as n over 2. N is 16 for us, right? So we know number of terms are 16, correct? So we can write this as 16 over 2 times the first term is 8 plus 83, right? Plus now the geometric sequence part, let's work on this. So we'll work on this side. Now that sum is a, the value of a is 2, and the value of r, the number of terms are 16, and it is getting multiplied by 2, right? So s of n in this case is equal to 2 times 1 minus 2 to the power of 16, right, divided by 1 minus 2. So that gives you the value, which is, we can write here, which is 2 times 1 minus, so let's use calculator to find the answer. We can use calculator later, but let me rewrite this answer here. 1 minus 2 is minus 1, correct? So this is also negative. Ultimately, you get a positive answer, correct? Anyway, let's add this and find our solution. So let's use calculator, right? So we have 8 plus 83 8 plus 83 times 16 divided by 2 is 8. Sorry, I should have used the bracket first, or let me just multiply with 8 later, right? So like this. So this is 728 plus this is 2 within brackets 1 minus 2 to the power of 16 bracket close, and we'll multiply or divide by -1, right? So this becomes positive 131,070, right? So when you add them up, let's add 728 to this, we get 131,798, correct? So that is what was supposed to be, right? So we have our solution here. So you need to remember these formulas to solve this question. Now let's look into part 2. We are given a sequence u1, u2, u3, where that is the definition. We need to find exact value for sum of 100 terms, 1 to 100. Okay, so let's look into these terms. That is the reciprocal, right? So I'll do this solution right here. We have u1 equals to 2 over 3. u2 is 1 over u1, that is 3 over 2. u3 will be 1 over u2, which is 2 over 3. So what you see here is that the terms are becoming, like there are only two types of terms. One is 2 over 3, the other one is 3 over 2, right? So when you do reciprocal of 2 over 3, you again get 3 over 2, correct? So like this, your series will continue. So all even terms are 3 over 2 and the odd number of terms are 2 over 3, right? But we have total of 100 terms, correct? So we have 100 terms like this. So let me just mark this place away. We'll just solve in the area given to us, drawing these lines so that they help you to understand. So in this case, the sum of the 100 terms where r is equals to 1 to 100 for ur will be, we'll have 50 terms with 2 over 3, right? So there are 50 terms with 2 over 3 plus 50 terms with 3 over 2, correct? So that is going to be the answer, correct? So you can add this, and so what you get here is 100 over 3 plus 150 over 2, right? Or just cross multiply. So we get 6 here, 200 plus 450, correct? Which is 0, 5, 6 over 6, correct? So that is, you can divide by 2 and you get the answer 325 over 3. So that becomes your answer for part B. So this exact sum is 325 over 3. Clear? Number 6. The function f of x is equal to minus 3x cubed plus 8x squared minus 9x plus 10, where x belongs to real numbers. Part A is calculate f of 2. Second part of A is write f of x as the product of two algebraic factors using the answer of 1a, right? B. Prove that there are exactly two real solutions to the given equation. Now, if you compare these two equations, the only difference is x to the power of 3 has become y to the power of 6, right? Part C is deduce the number of real solutions for theta greater than or equal to 7 pi less than 10 pi to the equation 3 tan cube minus 8 tan square plus 9 tan theta minus 10 equals to 0. Now here x cube has become tan cube theta, x square has become tan square theta, and tan theta is replacing x, correct? So that is the relation between the given equation and the polynomial. You can always pause the video, answer the question, and then look into my suggestions. So let's begin with the very first one to evaluate the value. So we need to just substitute 2 in our equation. So we get minus 3 2 cube plus 8 times 2 square minus 9 times 2 plus 10, right? So now we can use calculator to figure this out. So we have minus 3 within bracket we have 2 cube plus 8 within bracket we have 2 square minus 9 within brackets 2 plus 10, and that gives you 0. So we get 0 for this. So we found that f of 2 is 0. What does that mean? It means x minus 2 is a factor, right? Part B is right, f of x is a product of two algebraic factors. So from here, we know that x minus 2 is a factor. To find the second factor, we could perform division, right? So let's do the long division. So I'll use the space to perform division. So let me write like this. Okay. We have minus 3x cubed plus 8x squared minus 9x plus 10. We need to divide by x minus 2, right? So to take care of minus 3, I'll take minus 3x squared here. X cubed will get, right? So we get minus 3x cubed minus 3 times 2 is 6, minus minus is plus 6x squared. And when you take away, you get here 2x squared. Bring down 9x, right? So 2, we have to multiply by 2 to get 2x, rather 2x to get 2x squared. So we get 2x squared minus 2 times 2 is 4x. Now here we are left with minus 9 take away 4 will be 5, right? So 5x, bring down 10, which is plus 10 here. So minus 5 times, right? So that gives you minus 5x, that becomes 10, and the remainder as expected is 0. So write this as a factored form. So obviously we could write f of x as equal to x minus 2 times all this, which is minus 3x squared plus 2x minus 5. Is that clear? So those are the two factors. Now, prove that there are exactly two real solutions for this equation. So next equation for us is where x cube has been replaced by y to the power of 6, or x is replaced by y squared, right? So the only difference in these two equations is that we have y squared instead of x, right? Okay. Now to prove that there are exactly two real solutions to this equation, let us see for the first one, how many real solutions are there? Now, we have seen that there is one real solution for f of x, which is at x equals to 2. Now let's test this one, correct? So you can test using b square minus 4ac, correct? Okay, so I'm going to solve it here itself. So in this case, if I do b square minus 4ac, we have to check what we get. If we get this as less than 0, that means there is no real solution for this factor. Is that okay? For this factor, correct? That's what it means, right? So we'll do this testing here and then we'll conclude the result. Perfect. So let's find b square minus 4ac. So b square minus 4ac for f of x, we are doing for f of x, okay, is, now term b is 2, right? So it is 2 squared minus 4 times a is minus 3 and c is minus 5, correct? So which is 4 minus, so that becomes 5 times 4, 20 times 3, 60, right? Which is minus 56. Now that is less than 0, therefore the second factor has no solution. So we can say that f of x has only one real solution, right? And that is, so the real solution is x equals to 2 is the only real solution for f of x, correct? Now, what we have here is f of y. So in this case, we are given f of y, and what we see here is that y square is basically, so x has been replaced by, see, x has been replaced by y square, right? So y square is basically x, correct? In f of y. Now we know that x equals to 2 is the only real solution for f of x. So for f of y, what is x square equals to, right? So x square equals to 2, correct? Now x square equals to 4, squaring both sides. That means y equals to, we have to find now y, right? So x square is basically 4. So if I see, we could replace this x by y square basically, right? We should do like this, not x square. So y is actually square root of x. So that is the solution. So whenever you do square root, you have to write plus and minus, right? Or think like this. Y square is equal to x implies that y equals to plus minus square root of x, correct? So that gives you plus minus square root of 2. So these are the two real solutions, right? So we can conclude that f of y has two real solutions, which are plus minus square root of 2. Is that clear to you, right? So we concluded from the fact that if you relate these two equations, f of y is equal to all this, which is same as saying that y square is x, right? So since x has only one solution of 2, x equals to 2, y square will have plus minus square root 2 as its only solutions. Clear? So that is how we are going to answer part B. Now let's look into part C, which is deduce the number of real roots for theta which is greater than 7 pi and less than 10 pi. Now here what we have is a trigonometric equation which is in terms of tan, right? So let's see that this basically implies, so we'll do part C now in this space. So I'm using a different ink. So in part C, we can say that tan theta equals to 2 is the solution from part A. Is that okay? Because this is the equation, cubic equation in terms of tan. Right? Now if you see the tan theta function equals to 2, then tan is positive in these two quadrants, correct? So we have solutions in two quadrants. Now if you're looking into the domain 7 pi to 10 pi, that basically means, so if you go like this, first is 2 pi, then second term 4, and then 6 pi, and then this is 7 pi, right? Then 7 pi to one full circle, 9 pi, and this, right? So that is what you're looking for, correct? So you can see in going like this, we land up in 3 solutions, right? So when you go from 7 pi to 10 pi, then we have for every pi one solution, correct? Every pi gives you one solution. So within 7 pi, so first solution we get here, and then when you cross, so this is your 8th pi, you get the second solution, right? And then this is after your 9th pi, you get this solution, and then basically you are landing here, right? So that is not a solution, right? So 7, 8, 9, and 10. 10 is not included, right? So when you go like this, these are your 3 solutions. Do you see that? So every pi really gives you one solution. So from 7 to 8, 8 to 9, but then 10 is not included. Well, So you get basically three solutions. So you have three solutions. As shown in the diagram. Is that clear to you? So that is how we could actually solve this question. I hope that helps. So basically in this question, we have interpreted the cubic equation and its solution with different scenarios. Take up question 7, which is based on trigonometry. Now here we have two questions. 7a is to solve for x greater than or equal to 0 less than pi by 2. The equation is 4 sine x equals to secant x. Part 2 is to solve for theta between 0 to 360 degrees. The equation is 5 sine theta minus 5 cos theta equals to 2. Giving your answers to one decimal place. Solutions based on entirely on graphical or numerical methods are not acceptable. Now these two are very typical test questions, and I hope their solution will help many students. Now normally you have to answer in this portion, but I'll kind of provide the solution right here. So the first equation here is 4 sine x equals to secant x. Secant could be written as 1 over cosine. So we get 4 sine x equals to 1 over cos x. We can cross multiply, getting 4 sine x cos x equals to 1. Now you should remember the double angle formula here, which is 2 sine x cos x is sine 2 theta, right? So I'll write this as 2 times 2 sine x cos x equals to 1. So I'm taking this 2 here, so I'm writing half here, and 2 sine x cos x is sine 2x. Now as far as the interval goes, we are given x is between 0 to pi by 2. So 2x is going to be between 0 and pi, correct? So we need to find, this is a positive value, so we are expecting two solutions, correct? Sine is positive. Let's look into this. Now I'm using these colors only to explain you the concepts. In the test paper, you're going to write in black ink. So sine is positive in these two coordinates, correct? So let's say this angle is alpha. So let's find the angle alpha where sine is half. Now you know the exact values, right? Pi by, let me make the triangle here and then we'll show you the values. So this side is 1, this is 2, this is square root of 3, and we're talking about sine, so this angle, which is pi by 6. Sine of pi by 6 is half, correct? So this angle is, so we get 2x as equal to pi by 6, which is in quadrant 1, and then pi minus pi by 6, right? Pi minus pi by 6, and that is 5 pi by 6, right? So 5 pi by 6. So these are the two solutions. So from here, you know x is equal to pi by 12, and that is 5 pi by 12. Since it says giving your answer to one decimal place, right? So you could actually convert this to one decimal place. Well, that is for this one. So there is no restriction for part 1, correct? So we could write this as our answer. So we have our answer here, that the value of x is pi by 12 and 5 pi by 12. So that is the exact value, correct? Now let's see how to solve the second one, which is theta is between 0 to 360 degrees. The equation is 5 sine theta minus 5 cos theta equals to 2. Now we could actually write this as the equation is 5 sine theta minus 5 cos theta equals to 2, right? So that is, we can write this in the form of r sine of theta minus alpha equals to 2. Now where r is going to be equal to square of 5 plus square of 5 square root, right? These two, right? So which is square root of 50? Or you can write this as 25 times 2, which is 5 square root 2. As far as alpha is concerned, alpha is the ratio of sine and cosine values, right? So how do we get this? R sine theta minus alpha basically is kind of like this. R times sine theta cos alpha minus R times cos theta sine alpha equals to 2. So when you compare this with the original equation, then R, they are squares basically, right? So R cos alpha is basically 5 and R sine alpha is also 5, right? So what we have here is, when you just compare them, we have R cos alpha equals to 5 and R of sine alpha is also 5. Their ratio, tan alpha, will be 5 over 5. So their ratio, tan alpha, will be 1. So that tells you that alpha is tan inverse of 1, which is 45 degrees. So we get 45 degrees for alpha, right? Well, this is the method of doing it. I was trying to do it with a shortcut. So alpha basically is tan inverse of these two ratios, right? 5 over 5, correct? In this case, both are same. That's why I showed you that we are actually dividing that sine alpha by cos alpha, right? So basically that 5 over this 5. So we get alpha as 45 degrees, right? Now, we know alpha and we know r, which is 5 square root 2. We have this equation. So from here, 5 sine theta minus 5 cos theta equals 2. We can write this as r sine theta minus alpha equals to 2. And as you just saw, the value of r is 5 square root 2 sine of theta minus 45 degrees is equal to 2, correct? So that becomes your equation, correct? So it is simpler to solve. Now we can say sine theta minus 45 is 2 over 5 square root 2, right? And then we can calculate the value of theta. Perfect. We know that in this case, theta is between 0 to 360 degrees. So we can find all the solutions within this interval for this, correct? So let's do it. So now we'll actually push the page a bit. We'll begin with this equation, which is 5 square root 2 of sine theta minus 45 degrees is equal to 2. So I'm just bringing it here now. So that tells you that sine theta minus 45 degrees is 2 by 5 square root 2, or square root 2 by 5. Now sine is positive. That means we are looking for two solutions. One in quadrant 1, the other one in quadrant 2, right? So we are looking for these two solutions. So we'll find this value of alpha and then the other value, correct? So we know from here that we can write theta minus 45 degrees as equal to, we'll do sine inverse of square root 2 over 5, right? Shift sine inverse of square root 2 divided by 5. So that gives you 16.4299, and the other value will be 180 minus this, right? Since the other angle is that one, correct? So these are the two values we're looking for, correct? That is 180 minus alpha, right? So we'll do 180 minus the answer, that gives you 163. So the other answer is 163.57. Now theta is going to be equal to, we'll add 45 to this, right? So let me add 45 to this. So we get 163.57 plus 45 equals to, add 45, we get 208.57. One decimal place. We have to give up to one decimal place, so I will round it to 6 degrees, correct? And here we'll get 16.4 plus 45 equals to, in decimals, 61.4 degrees, correct? So those are the two answers which we get for the given question. So I hope the steps are clear. So it's kind of straightforward. Once you get this, you find the value. We just write this in the form of r sine theta minus alpha equals to 2, where r is equal to square root of 5 square plus 5 square, and alpha is tan inverse of 5 over 5, correct? So you get both the values, you get your equation, then solve it. Is that clear? So that is how we are going to solve this particular equation. I hope the steps are absolutely clear. Question number 8. So this question is based on quadratic equations. Let us see how to solve such a question. Figure 1 is a graph showing a trajectory of a rugby ball. The height of the ball above the ground, h meters, has been plotted against the horizontal distance x in meters, right? So both these are in meters. Measured from the point where the ball was kicked. So that is the point. The ball travels in a vertical plane. The ball reaches a maximum height of 12 meters and hits the ground at a point 40 meters from where it was kicked. So the maximum reached is 12 meters. So right in the center, it is going to reach the maximum, which is 12 meters. So let's say this is 12 meters, and that is the 40 meters mark, right? A. Find a quadratic equation linking h with x that models the situation. So we are going to assume here that's a parabolic path, right? And then we'll model. So our assumption is parabolic path. Now we could use the different forms of the equation. So capital H can be written as, if I use the intercept form, we have got 1 0 at 0, the other one is 40. So we can say a times x is this variable, x times x minus 40, correct? To find the value of a, we can substitute this. Highest point will be at the midpoint at 20, correct? So if I substitute 20, then the height should be 12. So from there we get a, I'm substituting 20 for x, so I got 20 minus 40, and that gives us 12 divided by, this is 20 times 20, but with a negative, 400, correct, is the value of a, right? So that becomes the value of a, which you could definitely simplify and write this as negative, dividing both by 4, will gives us 3 over 100, correct. So our equation can now be written as h equals to minus 3 over 100 x times x minus 40, clear? So that is how we can relate height with the distance x. Now, the ball passes over a horizontal bar of a set rugby post that is perpendicular to the path of the ball. The bar is 3 meters above the ground. Part B is, use your equation to find greatest horizontal distance of the bar from O, and part C is, give one limitation of the model. Okay, so let's begin with the limitation itself. So limitation could be what? limitation is no air resistance. Right? So that is one thing. No wind, right? So it follows a uniform motion as shown without any resistance. Now let's look into find the greatest horizontal distance for the bar. Now bar is 3 meters above the ground. So basically what we are saying here is that somewhere here it cleared the bar, and this distance is, well, I should have taken here. Let's take it here, right? This is 12.6, much less light, right? So let's say this distance here is 3 meters. We need to find the value of x when the height is 3 meters, correct? So we can substitute height as 3 here, and then we get minus 3 over 100, and we need to find the value of x, correct? That's the whole idea. Okay, so let's write this as, let's multiply them, x squared minus 40x. So to solve this, we can take it to the right side, and then we have a quadratic equation to work with. So 3 and 3 cancel, so we get minus 100, or you can say just 100, okay. I'm taking 100 to the other side. Let's write it plus, doesn't matter. So we just multiplied, cancel these 3, equal to, I kept minus here, so minus 3x squared plus 120x. Is that clear to you? So multiplying with negative gave us 3 and 3 cancelled, sorry. So let's do it like this. When you multiply here, multiply with cancel 3's, okay, so we get 1 here. So we get this as 100 equals to, open this bracket, with minus x squared plus 40x, clear? Now that becomes a quadratic equation. So we can bring all these together. So we get x squared minus 40x plus 100 equals to 0. So now you could actually find the solution using quadratic formula, right? So switches, we get the value of x. Let me do it here. Minus b, which is 40, plus minus square root of b square, which is 1600, minus 4ac, which is 400, okay, divided by 2 times a, right? So that becomes the value of x. So let's calculate this. So let's calculate the square root part, which is square root of 1600 minus 400, which is 20 square root 3, right? In decimals, it is 34.64. So we can add this to 40 because we want the greatest. So plus 40 and then divide by 2. It gives us in decimals a value which is equal to 37.32. So from here we got the height, use the equation to find the greatest horizontal distance of the bar, and it can be rounded to 37.3 meters, correct? So that becomes our answer. So this answer is 37.3 meters, correct? So I hope the steps are absolutely clear, and that is how it should be solved. Question number 9. Given that theta is measured in radians, prove from first principle that d theta of cos theta is minus sin theta. You may assume the formula for cos a plus minus b, and that as h approaches 0, sin h over h approaches 1, and cos h minus 1 over h approaches 0. Now, when we say use first principle, the very basic definition, let's say that we are given the function which is function of theta as cos theta, correct? We want d theta of the function f of theta, and that is using the principles of limit h approaches 0 for f of theta plus h minus f of theta divided by theta plus h minus theta, right? So that is the very basic definition. So we could write this as limit h approaches 0. Now when I say f theta plus h, function is cos theta. So it becomes cos of theta plus h minus f of theta is cos theta over theta plus h minus theta is h, correct? Now we could write this as limit h approaches 0. Cos a plus b formula we can use here, which is cos a cos b minus sin a sin b, right? So we'll write this, which is cos theta cos h minus sin theta sin h, correct? We already have cos theta here, everything divided by h. Now we'll use the properties of limit. Here you will notice that h is approaching to 0, right? So cos theta is basically independent of h, right? So what we will do here is that we can actually we can combine these terms, correct? We'll use this identity here. So we'll consider these two terms. We'll take cos theta as common factor. So we get limit h approaches 0. So using first and the third term, we get cos theta. So we have here cos of h minus 1, and here we get minus sin theta sin of h, and that means we could write like this also, correct? Where limit is on both. Is that clear to you? Using the properties of limit, we can rearrange this and write this as cos theta, which is independent of h. We can write this as limit h approaches 0 for cos of h minus 1 over h, right? Minus, here we can write this as limit h approaches 0 of sine of h over h times sine theta. Clear? Now this limit cos of h minus 1 as h approaches 0 is basically 0, right? So this part is 0, so we get 0 here minus. Now this limit is 1, so we get sine theta. So that shows that the derivative of cos theta is minus sine theta. Is that clear to you, right? So that is how, using first principle, we can derive this expression. Question number 10. A spherical mint of radius 5 mm is placed in the mouth and sucked. 4 minutes later, the radius of the mint is 3 mm. In a simple model, the rate of decrease of the radius of the mint is inversely proportional to the square of the radius. Using this model and all the information given, find an equation linking the radius of the mint and the time. You should define the variables that you use. Hence, find the total time taken for the mint to completely dissolve. Give your answer in minutes and seconds to the nearest second. Suggest a limitation of this model. So we'll actually basically assume that all throughout the mint which we're talking about remains spherical. So we'll write the limitations that it is always spherical. So that is our assumption, right? And now we'll just derive the formula from the given conditions. We are given that the spherical mint of radius 5 mm is placed. So initially the radius is 5 mm. 4 minutes later the radius of the mint is 3 mm. So in this case, at t equals to 0, the radius of the mint is 5. And it says 4 minutes later, radius of the mint is 3 mm. So when t equals to 4, then the radius becomes 3 mm. Right? This is in millimeters, and the time is given in minutes, right? So 4 minutes. So time is in minutes. So we'll define time, t is time for us. So we'll write time t in minutes. Is that correct? And radius r in millimeters. Right. So that is the time in minutes, okay? So we are given this. In a simple model, rate of decrease of the radius of the mint is inversely proportional to the square of the radius. So what we're trying to say here is rate of decrease means dr dt, right? Rate of decrease. So rate of decrease means dr dt is inversely proportional to the square of radius. That means dr dt is proportional to 1 over r square, and that gives you that dr dt is equal to some constant over r square. Is that clear to you, right? So that is how we are going to get our equation. Now, using this model and all the information given, find an equation linking radius of the mint. We want radius and time, r and t, right? We have dr here, we want r and t. We have dr dt, okay. We want time. That means we need to integrate. That's a differential equation, right? So let's cross multiply. So we'll use the space here. R square dr equals to k times dt. And then we can integrate on both the sides, right? Integrate on both the sides. So when you integrate this, r square dr, you get r cube over 3, right? So that is what you get. On this side, it is a constant. You're integrating with respect to t. So you get kt plus c. Now you can always find the value of c and k using the constraints. So c at t equals to 0 and r equals to 5. So we're going to use this condition 1 to find c, right? So we'll use that condition to find c. So r is 5 at t equals to 0. So we have 5 cube over 3 equals to k times 0 plus c. So that gives you the value of c as 5 cube over 3, right? So from here we get c is equal to 125 over 3. Is that clear to you, right? So now we have a relation between r and this, which we could write like, let me rewrite this. So we have r cube over 3 equals to kt plus 125 over 3, right? Now we need to find the value of k also, which we can find using the second condition. That is, when t equals to 4, r is 3. So r is 3, so we get 3 cube divided by 3 equals to t is 4, so 4k, right, plus 125 over 3. Clear? Okay. So that is, this is 3 cube divided by 3 is 3 square, so that is 9, right? So from here, all right, let's see. So from here we can find the value of k. So we get 4k equals to 9 minus 125 over 3, which is 27 minus 125 over 3. Correct? So we get that value as 4k. Let's use calculator. So we have 27 minus 125, which is minus 98 divided by 3. So k will be equal to, this is, let me write this, minus 98 over 3. So the value of k is minus 98 over 3 times 4, correct? So let's divide this minus 98 by 12. So what you get here is minus 49 over 6. So we get the value of k as minus 49 over 6, correct? So now that gives us the relation. So find the equation linking radius of the mint. Let me use different color to write down the relation now, which is basically r cube over 3 equals to minus 49 over 6 t and the C value is 125 over 3. Is that clear? So that is how we are going to get solution for part A. Now B is, hence find the total time taken for the mint to completely dissolve, giving answer in minutes and seconds to the nearest second, right? So completely dissolve basically means, so let's use another ink here. Completely dissolve basically means that R becomes 0, right? Okay. So that means R equals to 0. Find T. That is find T, correct? That is the equation. So in this equation, if I put R equals to 0, I get 0 equals to minus 49 over 6T plus 125 over 3. Clear? So let's take it to the left side. So we get 49 over 6T equals to 125 over 3. So that gives you T as equal to, cross multiply, 125 over 3 times 6 over 49. Okay, let's calculate. So we'll do 125 times 6, and then we are going to divide this by 3 times 49. So we get 250 by 49. In decimals, it is equals to 5 minutes, right? 5 minutes. And we have some decimal which is 0.10, something like this, right? So to convert this to seconds, what I will do is I'll take away 5 from here and multiply by 60 to get seconds, which in decimals is 6.12, right? So we get this 6.1 seconds. Is that clear to you, right? So that is how we are going to calculate this. So I hope you understood how we converted that to seconds, right? So all the decimal places which we had multiplied by 60. Now here we need to write our answer seconds to the nearest second. So therefore we are going to write this as 5 minutes and 6 seconds. Correct? So that is how we are going to solve this question. I hope the steps are absolutely clear. From the given information, we decided that time will be taken in minutes, radius in millimeters, the ratio where rate of change is inversely proportional. So we get dr dt equals to k over r square. Integrating, we got the result between r and t. We found those constants using the initial conditions given. And then it was simple algebraic solution to get the result. I hope you find it straightforward. Feel free to write question number 12. Prove that 1 minus cos 2 theta is equal to tan theta sine 2 theta, where theta is not equal to 2n plus 1 pi over 2 and belongs to set of integers. So this value will make tan theta as undefined, so that is a restriction. Part B is, hence solve for x greater than minus pi by 2 less than pi by 2 the equation secant square x minus 5 times 1 minus cos 2x equals to 3 tan square x sine 2x. Correct? So that is the question for you. You can always pause the video, answer the question, and then look into my solution. You're also required to give any non-exact answers to 3 decimal places, right, where appropriate. Okay. So to prove this identity, few formulas you should remember, which is we have sine 2 theta here. So a formula relating sine 2 theta is 2 sine theta cos theta, right? Cos 2 theta formula. So cos 2 theta in terms of sine theta can be written as 1 minus 2 sine square theta, correct? So we are going to use these 2 formulas to prove this identity. Okay, so let me just show it here itself. Less space we'll use for part B. Now, cos 2 theta is 1 minus 2 sine square theta. So we'll start with the left side. Which is 1 minus cos 2 theta. I'll write this as 1 minus. instead of cos 2 theta, I'm writing 1 minus 2 sine square theta, correct? So that's my left side. So when you open 1 minus 1, that becomes 0. And what we get here is 2 sine square theta, right? So what we get here is equal to 2 sine square theta. Clear? Now, what we really need is tan theta sine 2 theta, right? To get sine theta, to get tan theta, we need to have cos theta in the denominator. So what I can do here is we can multiply this by cos theta and also divide by cos theta, correct? So once you do that, what you get in the numerator is sine theta, so we'll just rearrange the terms, times 2 sine theta cos theta divided by cos theta, I'm writing here, mainly because I need tan theta, right? So sine over cos is tan, perfect, and 2 sine theta cos theta is sine 2 theta, correct? Clear? Which is same as the right side. So you could go any way to prove this, and that is how we are going to show it. So I hope that is clear, right? Now, part 2 is we are given an equation secant square x minus 5 times 1 minus cos 2x is 3 tan square x sine 2x. Now, we already know that 1 minus cos 2x is tan theta sine 2 theta, right? So we can rearrange this and we can write everything in terms of tan. Secant square x, secant can be written as cosine, right? And 1 minus cos 2x will write as tan theta sine 2 theta, correct? So let's do this proof right here. So first step, we'll do secant square x. What we are going to use here is these steps. 1 plus tan square x equals to secant square x, correct? So that is the property which we are going to use here. So instead of secant square x, I'm writing 1 plus tan square x. We already have minus 5 here, and this expression is basically equal to sine x sine tan x sine 2x, right? So we'll write this as tan x sine 2x, clear? The idea is we have similar terms on the other side, which is equal to, here we have 3 tan square x sine 2x. Does make sense to you, right? So that is how we're going to do it. Now, let's simplify this. So what we get here is tan square x minus 4 times tan x sine 2x, and we can bring this to the left side, so we get minus 3 tan square x sine 2x equals to 0. So basically what we have here is that we can take the tan x sine 2x common, right? So we can take tan x sine 2x common. So we get tan x sine 2x. Within bracket from here, we get tan square x minus 4, right? And from this side, because we took tan x sine 2x common, we get 3 tan x, right? So what we get here is 3 tan x minus 3 tan x equals to 0, correct? So we get a quadratic equation here, but here we have 2 factors. We can actually factor this also. So these factors will give us solution. Let's rewrite. So we have tan x sine 2x. Now that is a quadratic equation which, let me rewrite, tan square x minus 3 tan x minus 4 equals to 0. We need product of minus 4 and sum of minus 3. So that means 4 times 1, right? So we could factor this. 4 times 1 can work for us. So we can write this as tan x sine 2x. So 4 times 1, 4 is negative. So we have tan x minus 4 times tan x plus 1 equals to 0. Clear? So we get 4 factors. Now each one of these factors will give us the solution. So tan x equals to 0. And remember, we are working in this domain, which is minus pi by 2 to plus pi by 2. For sine 2x, if I write 2x here, in that case the domain will become, if it is 2x, in that case it will be from minus pi to plus pi. So that's important to remember, since sine 2x equals to 0 will give us values within this, but pi and minus pi are not included. This is very important to understand. Is that clear to you, right? So for tan x equals to 0 and sine 2x equals to 0, we get the same answers. For these, we get, if I want to write sine 2x equals to 0, so that basically means x is equal to 0 degrees, correct? So that is one way. Second is, we want this factor to be 0, so we have tan x equals to, equals to 4, and we have tan x equals to minus 1, right? So x value is tan inverse of 4, and here we have x value as tan inverse of minus 1. Now within this time period, let's look into this slightly more details. We need positive values. So basically, we are working for x within this domain, correct? From minus pi by 2 to plus pi by 2. When I say it is positive 4, that means we are looking in this quadrant, correct? And when we say minus 1, we are looking into this quadrant. This is for minus 1, correct? So that minus 1 value will be minus pi by 4. So this value is x is equals to minus pi by 4, correct? And for this, I need to use calculator. So we do tan inverse of, so let's convert this to radians first. So we'll change the mode to radians, which is 4. Okay. And now we'll do tan inverse of 4. We get 1.32, right? We have to round this to 3 decimal places. So this gives us x equals to 1.33 decimal places, correct? So 3258, so we'll write 326 radians. Correct? So not 0 degrees, 0 radians. Both are same though, but that is how we're going to do. Perfect. So I hope the steps are absolutely clear. Let me rewrite the answers here. So we get answers as x equals to 0, minus pi by 4, that's the exact value, and 1.326 radians. All are in radians. Correct? So that is how we need to solve this. Excellent question. Question number 12. I hope solved. Question number here is based on partial factoring and derivatives. The question is 1 plus 11x minus 6x squared divided by x minus 3 times 1 minus 2x is equal to a plus b over x minus 3 plus c over 1 minus 2x. Find the values of constants a, b, and c. Then we are given the same function for x greater than 0, and we need to prove that f of x is decreasing function. You can always pause the video, answer, and then look into my suggestions. Now, to find the constants a, b, and c, we'll basically we'll just cross multiply and then rewrite this particular equation. So we have here 1 plus 11x minus 6x squared is equal to a times both these factors, right, which are x minus 3 times 1 minus 2x plus b times, so when you multiply these two factors, x minus 3 gets cancelled, so you get 1 minus 2x here, plus c times x minus 3, correct? Now to find the values of a, b and c, what the technique is that we can substitute x equals to 3, this will be 0, that will be 0, we can find b, and if I substitute x equals to half, we can eliminate b, and a find c, right? So that's what we are going to do. So first substitution, let's put x equals to 3. Now in that case, the value of 1 plus 11x minus 3x squared will be what? So let's calculate this, right? So what we'll get here is 1 plus 11 times 3 minus 6 times 3 squared will be equal to, we'll calculate this. So when you put 3, this term is 0, that term is 0, we get b minus, we get this term, right? So we get b times 1 minus 2 times 3, which is 6, correct? Now we can solve this equation and find the value of b. So what we have here is 1 plus 11 times 3 minus 6 times 3 squared is 9, so that is minus 20. So we get minus 20 equals to 1 minus 6 is minus 5b, or from here we get the value of b as minus 20 divided by minus 5, and that gives you 4. So we get b. Now let's find the value of c. We'll substitute x equals to half, so that term will cancel. So now let's do x equals to half. In that case, what we get here is 1 plus 11 by 2 minus 6 by 4 is equal to, that these two terms become 0, we get c half minus 3, correct? So let's calculate what c is. So we have 1 plus 11 by 2 minus 6 divided by 4, and that gives you 5. So what we have here is 5 equals to half minus, so you get the 0.5 minus 3, which is minus 5 by 2. So you get minus 5 by 2c, correct? So from here we can get what c is. So 5, which is a negative, times 2 over 5 is equal to c. That gives you the value of c as negative 2, right? So we got b and c. Now to find the value of a, we know b and c. We'll substitute some value of x, let it be 0. So we'll now substitute x equals to 0 in our equation and see what do we get. So we get 1 on the left side, so that will give us 1 equals 2. 0 gives us minus, this is minus 3a. When you put 0 here, you get b times 1. So let me write here plus b. And here we get minus 3c, right? Minus 3c. Now, so that gives, we know b and c values, right? So we get here 1 equals 2. Let me push the page a bit. Okay. Minus 3a. The value of b is 4 plus 4 minus 3 times minus 2 makes it plus 6. Okay. So that is 10. So we get the value of a as we'll take it on this side. So that gives us a minus 10 plus 1 equals to minus 3a, and that gives you the value of a as equal to, this is minus 9. So a equals to 3. Okay. So we get our expression for all the values now. So we can write down what the right side is. So a is 3. So what we basically found was that the value of a came out to be 3. For b it was 4. And for c it was -2. Correct? So we can rewrite the given rational function as equal to 3 plus 4 over x minus 3 minus 2 over 1 minus 2x. Clear? So that is how you could write this, and those are the values for a, b, and c. Of course, it has restrictions that x cannot be 3 and x cannot be half. Now we'll do part 2, which is we need to show that all this function is decreasing, and we are taking the interval when x is greater than 3, right? So, okay. So what we'll do is, we know this expression is basically equal to, we can write this as equal to 3 plus 4 times x minus 3 to the power of minus 1, right? And here we could write this as plus 2 times, we can write this as 2x minus 1, correct? So 2x minus 1 to the power of minus 1. Now to show that this is decreasing, we need to find the derivative, correct? So let's do this here. So let me just copy the expression and then we'll find the derivative. So for part b, we have f of x as equal to 3 plus 4 times x minus 3 to the power of minus 1 plus 2 times 2x minus 1 to the power of minus 1. So the derivative of this function will be, that is 0, so, right? So this is minus 1. So we get minus 4 times x minus 3 to the power of minus 2. And here we get minus 2, and 2 times 2 is 4. Okay, so we get 4 here. 2x minus 1 to the power of minus 2, which clearly shows we have minus 4 over x minus 3 whole square. So this is a negative term, and this is again another negative term, minus 4 over, we have a 2x minus 1 whole square. So both are negative terms, and therefore we can clearly see that f dash x is less than 0. So that implies that f of x is decreasing. Is that clear, right? So that is how we can prove it. So the question here is, figure 2 shows a sketch of part of the curve C with the equation y equals to x ln x, where x is greater than 0. The line L is normal to C at point P, EE. The region R, shown shaded in figure 2, is bounded by the curve C, the line L, and the x-axis. Show that the exact area of R is AE square plus B, where A and B are rational numbers to be found. Very good question. So I'd like you to go through this, try to understand how do we find the area of this shaded region R. Now to begin with, what we are given here is that this line is perpendicular, right? Normal. So we know this is perpendicular. So the idea is to find the equation of this line, and we need to find this point also, which is the x-intercept, right? In fact, we need to find this point also, the where the curve cuts the x-axis. So our area will be now defined by these 3 points. So let's begin by finding the equation of this line, then the x-intercepts, and then we'll find the area under the curve. Perfect. So what I will do here, since there's less space on this page, we'll take it on a fresh page to find the area, rather the equation of the line. So I've copied this part of the question here, which is find the equation of line normal to the curve y equals to x ln x, right? That was the equation given to us, right? At the point P, EE. So that's what it is. So we are given the curve which is y equals to x ln x, right? We know that x is greater than 0. Now dy dx, which is the derivative, will be, we can do product rule. So 1 times ln x plus x times derivative of ln x, which is 1 over x, correct? So dy dx is basically equal to ln x plus 1. Now we need to find this slope at x equals to e, right? So we have dy dx at x equals to e as ln e plus 1. Now ln e is 1, so we get this as 1 plus 1, which is 2. So that is the slope at that point for the curve, right? So what we really found was, let's reconstruct our graph here. Okay, let's do it here. So I'm just making a rough sketch for the graph, which looks kind of like this. So we found equation of the tangent line. Let me just draw a tangent line. So this is the curve C. So at this point we got the tangent, right? So slope of this is basically 2. So what should be the slope of the tangent? Normal. Normal will be negative reciprocal, correct? So we want to find this slope m, right, of the normal. So what should that be? So slope of the normal line, so that perpendicular line will be negative half, correct? So we know the slope of this line. Now let's find the equation of this line. So we have a point here P, which is EE, correct? So we have a point P, which is EE, and we have the slope, which is minus half. So from here we can write down the equation of the line. So let's say line is L. So the equation of the line will be, we can write this as y minus y value equals to slope x minus e, right? So that is how we could get the equation. Just multiply by 2. So we get 2y minus 2e equals to minus x plus e. Bringing them together, we get x plus 2y. We'll keep these constants on the right side, we'll find the x-intercept. So that gives us 3e, right? Okay, so that becomes our equation of the line. Now let us extend and find the x-intercept. Let's find the x-intercept of this line of L, correct? So at x-intercept, y value is 0, that is to say y equals to 0, okay? So substituting y equals to 0, we get x equals to 3e, right? So this point is 3e. All right, okay. Let's also define and find this particular point also, and so we'll find the x-intercept for curve. Curve C, right, which is given by the equation y equals to x ln x, right? So if I substitute 0 for y here, I got 0 equals to x ln x. So that gives me two values, and that is we have x equals to 0 and we have x equals to 1, correct? So these are the two values. So this point here is 1, correct? And that is 0. Is that clear to you? So in a way, we got a triangle. Now let us see how to find area of this particular triangle. That means we are interested in this area, correct? Okay, so let's get back to our question and then we'll continue from here. Okay, so here is our original question. We found all these points. We found this x-intercept is at 1 and that one is at 3e, right? Equation of our line L is equation of the line L, let me write down here, was what? So equation of the line was x plus 2y equals to 3e, right? So we get x plus 2y equals to 3e. So that is the equation of line. Now we need to find the area of this portion. How do we do that? Well, one of the way could be that we can just drop a perpendicular from here, right? So if I drop the perpendicular, I can say that this is part of two areas. One is area of the triangle. So let's call this point as Q, right? And let's call this point as R, not R. This is something else, this is T. Okay, so one is a triangle, the other one is a curve. So area of the curve we can find using integration, and area of this triangle we can do half base into height, correct? So we know E means this side up to here is E. So we have 3E here, so this should be 2E. Is that clear to you? As far as R is this height is concerned, it is also E, correct? So from here we can find area of the triangle. So let's find area of triangle. Which is PQT for us. Okay, so this area is half of base times height, which is half of base is 2E, right? 2E, and the height is E. Right, so 2 cancel, we get E square. So we get the area of the triangle, which is half of base, which is 2E, times height, which is E, correct? Now we need to find the area of the curve, which is between x equals to 1 and x equals to E, right? Between these two portions, correct? So now we need to find area of the curve. Let me write down here. So let's calculate the area under this curve. So which basically will be integral from 1 to E, right? So from 1 to E under the curve C, whose equation is x ln x, right? So x ln x dx. So we need to figure out this area. Now we can do this using partial fractions. So we'll use that formula, integration by parts. So we'll actually find this integral by the formula for integral by parts, which is, let me write down the formula in a different ink. So what we have basically is that if we have, let me write the formula here. So the integral of u dv can be written as uv minus integral of v dv, correct? That is how we figure it out. So we need to only identify what to take as u and what to take as dv. So let's take u as equal to ln x. In that case, du will be 1 over x, and let dv be equal to x. So v is the integral of this, which is, well, we should write dx here, 1 over x dx, right? As far as dv is x, so v will be x squared over 2. Right? So that is what it is. So using this formula, this integral will be equal to what? So the integral of from 1 to e for x ln x dx will be equal to product of u and v, which is x squared over 2 ln x, minus integral of these two, v du, right? That's what it is. So it is x squared over 2 times 1 over x dx. And we have the limit 1 to e, correct? So that is what it is. Now, let's simplify this. Well, here x and x will cancel. Let's do this, kind of cancel this portion. So we have x over 2. So we can write down the integral. So we get this as x squared by 2 ln x minus, so here we get x squared by 4, right? 1 to e, correct? Now let's find the area. Substituting e, we get ln e is 1, so we get e squared by 2. Here we get minus e squared by 4. and then we take away, substitute 1 here. So let me write in brackets. So minus 1, that becomes 0, right? And this becomes minus 1 over 4, correct? Minus 1 over 4. So that gives you e squared by 4, and this becomes plus 1 over 4. So we get this area. So the area for the curved portion here, which is, let me shade it in a different color, is this much. Clear? Now we need to find the total area. So let me write the total area here. So we get total area will be equal to sum of these two, right? So which is e square, the triangle area, plus this one, which is e square by 4 plus 1 over 4, right? So that gives us 5 over 4 e square plus 1 over 4. Clear? So now that is how we find the area. Now the question actually was here, show that the exact area R is a e square plus b, where a and b are rational numbers to be found. So when you compare here, we get a as equal to 5 over 4 and b is equal to 1 over 4. Is that clear to you? Correct? So that is how you're going to answer this question. So I hope you understand all these steps. This was a very beautiful question, extremely important to understand. So what we did was, we first found the equation of the normal, right? Then we found the intercepts for both the curve and the normal. So that defined our area. And then we use integration to find area under the curve from 1 to this portion E. And area of triangle formula we used, half base into height. So that was fast. Adding them up, we did get an expression which was expected, which was kind of a square plus b. Comparing the coefficients, we got the value of a as 5 over 4 and b as 1 over 4. Perfect. One is the last question of this test paper, extremely important, and I hope its solution will help many people globally. The question here is, a scientist is studying a population of mice on an island. The number of mice n in the population t months after the start of the study is modeled by the equation n equals to 900 over 3 plus 7e to the power of minus 0.25t, where t belongs to real numbers and is greater than or equal to 0. A. Find the number of mice in the population at the start of the study. B. Show that the rate of growth dn dt is given by dn dt equals to n times 300 minus n over 1200. The rate of growth is maximum after t months. Find, according to the model, the value of t. According to the model, the maximum number of mice on the island is p. State the value of p. Right. So I'd like you to pause the video, answer this question, and then look into my suggestions. Now part 1 of this question is to find the number of mice in the population at the start of the study. That means when t equals to 0. So we could substitute t equals to 0 here and find that answer, right? So we have n equals to 900 over 3 plus 7 e to the power of minus, and when you substitute 0 you get 0, right? So anything to the power of 0 is 1. So what you get here is basically 900 divided by 3 plus 7, right? So we get n equals to 900 by 10, which is 90. So to start with, there are 90 mice. So the number n initial or starting, right, is with 90. Now part B is, show that the rate of growth dn dt is given by this particular expression, right? So let's find the derivative of the given function. I'll take it on a fresh page, right? So now we need to show that the rate of growth dn dt is given by this particular expression. So let's find the derivative of the given function and then we'll write it in the given form. So I've copied this question on a fresh page to solve further. So the question now is, the number of mice n in the population t months after the start of the study is n equals to all this, and we need to show that dn dt is basically equal to n times 300 minus n over 1200. Right? So that is what we need to show, correct? So let's try to see how. Okay, so n is given to us as equal to 900 over all this. I can rewrite this as 900 times 3 plus 7 e to the power of minus 0.25t to the power of minus 1. So we get dn dt as equal to 900 times all this, which is 3 plus 7 e to the power of minus 0.25 t to the power of minus 2 times the derivative of inside function, which is 7, the whole thing, which is, we can write e to the power of minus 0.25 t times this, which is minus 0.25. Okay, so that's what it is. So which we can write here as, no, well, negative 1, this was negative. So negative 1 times all this to the power of negative 2 times this derivative. Now this minus and this minus becomes plus. You know, 0.25 is basically 0.25 is 1 over 4. So we'll write this as 1 over 4, correct? Okay, so what we get here is minus and minus makes it positive. So we have in the numerator 900, and this term comes in the denominator. We have this term here, which is 7 e to the power of minus 0.25t, right, times 1 over 4. Okay, so we'll write that 4 here, right, times 1 over 4. And all this is also in the denominator, this term, which is 3 plus 7 e to the power of minus 0.25t whole square. Perfect. So that is the derivative, rate of change of the population of mice with time. Correct. But we have to write in this form, which is n times all this. Well, to do that, we may have to work with our original equation a bit. So let's do that part. So what we are given here is that n is equal to 900 over original equation, 3 plus 7 e to the power of minus 0.25t. So we can just cross multiply. So we get 3 plus 7 e to the power of minus 0.25t is equal to 900 over n. So this portion here can be replaced by 900n, correct? So we get one term in n. Now we have replaced this also by something in n. Well, so this portion will be what? Let's rewrite. So we could also write this as 7 e to the power of minus 0.25t equals to 900 by n minus 3, correct? So that portion. So this portion here could be replaced by this term. Is that clear to you, right? So let's rearrange and write it down. So what we have here is 900 over 4. 7 e to the power of this we are writing as 900 over n minus 3. Okay. And the denominator we are writing that as 900 over n whole square. Correct? Now it's a question of rearranging. So we get this as 900 over 4. N square we can take on the top, right? So we have 900 over n minus 3 times n square divided by 900 square. So we can cancel these 900s right? So we get this as, so when you open this bracket, okay, so when you open this bracket here, you get one of these gets cancelled. Let's open this. So we have here, when you open this up, okay, so we have 900 n minus 3n square in the numerator divided by, right? So one of them gets cancelled, 3n square, and denominator is 4 times 900. Correct. We don't want this. So we want 300. Let's take 3 common now. So we can take 3 common with n. Okay, so 3n is common. So when you take 3n common, we get 300 minus n in the numerator, and we get 4 times 900 in the denominator. So now it simplifies to, so 3 goes 3 times, so we get n times 300 minus n divided by 4 times 300, which is 1200, right? So what we did was, we cancelled this 3 with this 300. And 4 times 300 is 1200. So we got n times 300 minus n. Perfect. So we have shown this part. So that becomes the rate of change of population of mice with time, right? So that is d and dt. So I hope that is clear. So let's continue with our question, next part. Now let us solve part B and C in this fresh page. We have already shown that rate of change of number of mice is given as n times 300 minus n over 1200. Part B is, the rate of growth is maximum after t months. Find the value of t. So we have to find the time when the rate of growth is maximum. So what we just found here was that dn dt, rate of growth, is basically equals to n times 300 minus n over 1200. Now this is like a parabola if you look at it. So when is this maximum? We need to find maximum, right? So basically, if I sketch this, I will get a graph which will be kind of like this. For the rate of growth, right, and the number of mice. So when the number of mice is 0 and this is 300, those are the two zeros, and the maximum will be right in the middle. So we get maximum rate of growth for n equals to 150. Clear? But we need to find t when we get the number of mice as 150. That is the whole idea, right? Okay, so the formula is n equals to all this. So let's place this in the formula here. So the formula here is n equals to 900 over 3 plus 7 e to the power of minus, let me write t over 4 here. So in this formula, if I replace n with 150, I get 150 equals to 900 over 3 plus 7 e to the power of minus t by 4. So let's cross multiply. So we get 3 plus 7 e to the power of minus t by 4 equals to 900 over 150, right? Which goes 6 times. Correct? So let's solve for t here. So we have 6 minus 3. So 7 e to the power of minus t by 4 equals to 6 minus 3. So we have e to the power of minus t by 4 equals to 3, and then we'll divide by 7. Now taking ln on both sides, we get minus t over 4 equals to ln 3 over 7, correct? And so we get t as equals to minus 4 times ln 3 over 7. So let's calculate this value. So what we get here is ln 3 divided by 7 equals 2, and we multiply this by 4. So we get we get, and that is minus times that negative value will give us 3.389. So I'll write this as 39 months. Is that clear to you, right? So that is how we could find this. So we get t as equals to 3.39 months. Or 3.4 months we could have written. Okay. Now the last part of this question is to state the maximum number of mice. So how do you find maximum number of mice? Okay. Now see, maximum number of mice is not the maximum rate of change. Remember that. Maximum occurs when the rate of change is 0, right? So maximum number of mice will be at critical number. So we have to write d and dt equals to 0, right? That is a critical number. So in our case, we get two values. One is n equals to 0. The other value is n equals to 300, right? Now we know that the number of mice cannot be 0. Right, so at 300, let us find the rate of change, whether it is increasing, decreasing, or what is going to happen. Okay, so at n equals to 300, if I take a value of the mice more than or less than 300, so we can test. Basically, we need to check for maximum at n equals to 300, correct? So what we can do here is basically take a point on the left side and the right side of 300, right? So, okay, let's do it here. So if I take a value which is, let's say, more than 300, so let's say this is 300, right? So we have a test point 301 and 299, let us say, right? So in that case, the rate of change d and dt, if I take a value which is less than 300, then both are positive, correct? So the rate of growth will be positive, correct? So d and dt is positive. If I take 301, this becomes negative. So we do have a maximum at 300, right? So therefore, maximum number of mice equals to 300. Is that clear to you, right? So that is 300. So that is how we are going to get this answer. So I hope all the steps are absolutely clear. We began with this particular formula, found rate of change to be matching with what was given to us. And then we also found the time when we get the maximum rate of change. And lastly, we got the number of maximum mice, which we did by analyzing the first derivative, that is rate of change of the mice. Hope you find it interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Thank you and all the best.